How's it going, everyone? My name's Timothy Servanjak. I'm one of the representatives from AMO working as the manager of network modeling and information. And I'm on the wrong slide already. Here we go. So I guess today's talk is for software intensive systems, and a lot of software intensive systems that will make up a digital twin. So for example, when we're trying to model our power grid, and the key part is, as everyone's talked about so far today, is the data and model quality is becoming really important if you want to accurately represent your system in a digital twin format. So move to the first slide. So I guess the flavor I'm going with this presentation is why software engineering fundamentals are becoming more important. As everyone's noticed, we've got an increasing penetration of renewables. Levels of asynchronous generation is growing significantly in Australia. We're probably hitting a lot of the problems everyone's probably talked about today. And if you want to have a digital twin that's made up of all these underlying systems, the software engineering is going to become more important. As we talked about, that configuration management of models, how well they're qualified and tested. And when you group all that together, all the interactions is really going to be underpinned by the quality of the individual models that make up the overall system. Now, I guess the first thing you got to think about when you decide you would like to build a digital twin is what is the intent of that digital twin? How critical are the decisions you're going to make from that system? As was in the last presentation, not everything has to be accurate. It depends on the answer you're trying to look for. But in today's world, with the complexities and the interactions, if you want to make operational decisions or really critical engineering decisions, you need a really high accurate digital twin. And performance comes into the situation as well. How quick do you need that information? Now that becomes a balance of how accurate you want it versus how quick it has to be. And then in most cases, you don't build a digital twin from scratch. You've got a lot of legacy data, a lot of underlying information and models. Now, the synchronous generation is probably pretty easy to develop or represent compared to a software intensive system or asynchronous generation. And I think terminology becomes a really big part. How do you define quality? I think for me, one of the biggest things of how you define quality is accuracy and precision. All these things come into a part of how your model reacts and how much you can trust it. Now, I guess software intensive systems, software is an interesting beast. It's not the same as hardware. It's flexible, but it's got its pros and cons. Now, when you've got highly qualified software, if your software under a certain condition, XYZ says turn off your power plant, that will happen every time. It's not necessarily a software bug, which is the problem. It's possibly your bad requirements as well. So requirements are a really big factor. Just because you've tested your software really, really heavily, it doesn't mean it's going to behave the way you expect it all the time, especially when you get random hardware failures in the mix. Now, I guess a good way to explain things to me is the big difference between software and mechanical systems is software, if you have a software bug, that bug will be realized 100% of the time. Every time you hit that condition, you'll get the same result. Compared to a mechanical system, it operates on hours of operation, number of cycles, and then it eventually fails, where software, that condition will produce the same result every time. Now, when everyone thinks of software, they just think of testing. But all that testing is a level of confidence that your software meets requirements. And when you test it, it only gives you confidence in the area where you've been testing. And now when you're running a digital twin, where do you want it to be useful? In normal operations or when stuff starts going wrong? When you want to rely on these tools, it's normally when stuff starts going wrong, but have your models, has your system been tested in those areas of operation? So it's always the case, you think everything's really good till you hit those extreme conditions, and then you get the unexpected results, but by then it's too late. So that's why testing quality is going to play a huge part in the future of how we run a system, work with the OEMs, have that whole data life cycle of people who submit models, we test how they run, we send data back. It's a continual life cycle where everyone's playing a part and we're all going to have to work together to get the right outcome. So I guess the theme of the conversation is why the underlying models and data so important. Because if you want to rely on your digital twin for the decisions you're going to have to make to operate the power network or even planning in the future, you got to trust the data that's coming out of all those data and models and how they interact in a complex system to be able to trust your digital twin and the results you're going to get out of it. Now, I guess one of the questions for me is can you develop a model that represents a real system, a software intensive system? I guess my point of view is I'm leaning towards you need the actual source code or the actual representation of how the plane operates. People think machine learning or data analytics is a way to build a representation of the system, but for software, I don't think that's possible. So it really comes down to the fundamentals that we've got to start introducing through the whole life cycle of product design, development, obsolescence. Even when you start looking at things like compilers, how do you maintain a system over 30 years when it's stuck on a compiler until Fortran 2000 and something? So all this stuff has to be considered and viewed in an overall approach. And trying to line that all up now when you've got legacy system and models is proving to be a really big challenge. So I guess in conclusion, I'm trying to say with the way the industry is going and the reliance on inverter-based technologies, software is going to become really important. And that starts through the whole software life cycle. And the quality of these models is really going to underpin how useful your digital twin is. And I guess that's also relative to the decisions you're trying to make and the answers you're trying to get out of all these digital twins. So I guess that's me. I guess I was nice and short and made up some time for the last few presenters.
Well, thank you very much, Tim. So we'll move on to Jean. And I would just like to remind people that you can already send your questions through the GoToWebinar question section, and we'll answer them in the Q&A after Jean's presentation.